Welcome back. In this segment, we're going to talk about repetition. Up until now, we've been using sequence and selection. So sequence is the simplest of all control structures. It really isn't a control structure at all. You start at the beginning and you execute one line of code in sequence. And then selection, we talked about using the if-else statement to selectively execute lines of code. In this segment, we're going to talk about repetition, which is repeatedly executing some lines of code. The syntax that we'll look at first is for the while loop. The syntax for the while loop looks almost the same as an if statement, except the keyword is while instead of if. So we have while the condition is true, execute these lines of code. So in this case, every time you come to the bottom of the loop, you go back up to the top and evaluate the condition again. When the condition is true, go in and execute the body of the loop, and you can keep doing that forever if your loop is called an infinite loop, or eventually that condition will be false and the loop will be over. So here's our first example of a repetition using a while loop. We're going to implement the very simple spec of output the integers from 1 to 10. So you could just write 10 printf statements, 1 through 10, but instead we're going to execute one printf statement 10 times. So have a look at the while loop. We have a condition while count is less than or equal to 10. We're going to keep looping until that condition is false. The count variable starts at 1. So the first time through the loop, we're going to print out the value 1, and then we'll say count gets count plus 1. That statement says take the old value of count, add 1 to it, and then put it back into the same variable count. So we have a counter variable that each time through the loop will increment by 1. And each time through the loop we'll print out the next value that's in that count variable. Here are a few examples that we'll look at. We'll actually go into the development environment and implement. For example, output the multiples of 5 less than 100. So we want to output 5, 10, 15, 20, up to, but not including 100. Output the even numbers in descending order from 70 to 50. And here's a more interesting one. Sum the numbers from 1 to 100 and output the result. What is the sum of all the numbers between 1 and 100? 1 plus 2 plus 3? I'm sure I don't know. But it will only be a few lines of code, one loop to implement that, and we'll look at that in the development environment. When you're starting out programming, it's quite difficult to get the loop to have the behavior that you need it to have to solve the problems. And I like to tell people to think about the 3 things that you need to understand the loop's behavior. Where will the loop start? Where will it stop? And how do you get there? A lot of loops, how do you get there is just go to the next one, or by ones is how you get there. Sometimes you want to get there by 5s or by 2s. If you think of these other specs that are on this page, you might not want to get there wherever you're going in steps of 1. Well, let's go into the development environment and start looking at writing while loops. Here we are in the development environment. I made a new project and a new C file called myloops.c. And what I'd like you to do is to catch up to this point. So pause the presentation and get the Development Studio running and type in this loop. This is our first loop that outputs the values from 1 to 10. So it's a really very simple behavior loop, but it's important that we understand its behavior exactly. So start typing that one. And what I want us to do is to watch the behavior of this loop in the debugger. So I put a breakpoint here. on the while loop. So each time we enter the loop, we can look at the condition and we can watch the behavior of the loop as it executes. So you can put F5 or click on that green triangle that points to the right. So we have one variable count, and it has 1 in it. And now, while count is less than or equal to 10, is that true or false? Excuse me, 1 is less than or equal to 10. That's true. So when we execute the next line of code, we're going into the body of the loop. So we're going to output the value 1 with a space before and after it, and now execute this statement, count gets count plus 1. Watch the value down here of the variable that's in count when we execute that line of code. So count had 1, add 1 to it and put it back in count, and count now becomes 2. This development environment is nice enough to change the values to red that have just recently changed in this excuse me, in this locals window. So we're at the bottom of the loop now. If we execute this line of code, which is just the end of the loop, where do you expect us to go? Well, we're going to go back up. So this is the difference between a loop and a while, an if statement. At an if statement, you do the lines of code in the body only one time. And in a repetition statement, we're going to do them over and over while this condition is true. So now count has the value 2. 2 is less than or equal to 10. That's true. So we're going in. We're going to execute this line of code, output the value 2, output the value 3, and we can watch the behavior of the loop. Remember that your code shouldn't be hiding anything from you. If you have the feeling that, well, you wrote the code and you ran it and it didn't do what you wanted, it's because one or more of the statements isn't written correctly, and you can look at the exact behavior in the debugger executing one line of code at a time. Now, I've stopped stepping through here because I wanted to point out that the variable count has now become 11. We executed the body of the loop. The last thing we did was increment count to 11. We're going to go back up, execute the condition. Count is less than or equal to 10. It's false. 11 is less than or equal to 10 is false. The first time we execute that statement when the condition is false, we fall out of the loop and start to execute again in sequence, whatever comes after the loop. So there's our very first loop, and I want to now go back and look at some of the other specs that we had put on that PowerPoint slide, and let's try making a few more of these loops just for practice. So here's one. Output the multiples of 5 less than 100. And I'll put the spec, it's a very simple spec, here as a comment. Okay, output the multiples of 5 less than 100. Where will we start, where will we stop, and how will we get there? Well, what do we want the output to look like? 5, 10, 15, 20? Let's start at 5. So we'll initialize the control variable to 5. And where do we want to stop? Less than 100. So let's change that to 100. And we'll say that while the count is less than 100, we'll keep going. And how do we want to get there? Well, the next thing we want to do after 5 is 10. So instead of steps of 1, let's change this to steps of 5. Okay, I don't expect you to be able to figure out how to get the behavior of the loops to work as quickly as I did that. I try to encourage people that any time that you spend making these loops work is a good investment, because the next time you come to a loop of the same complexity, it will be much, much faster. Okay, our build succeeded. Let's run to the breakpoint. I'm pushing F5 now to do that. And we have a variable count, which has 5 in it. 5 is less than 100. Let's step, output the 5, increment to 10, output the 10. So now we are outputting the multiples of 5. If you get tired of clicking through this, you can hit F5 and it will hit the next breakpoint each time. So I'm pushing F5, 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 and we're executing the loop one time. Now, I wonder if we stopped in the right place. The spec said less than 100, and we didn't output the value of 100. So we've matched what the spec says. So the places that you might make a mistake in implementing the loop, the most common one is to stop in the wrong place. Let's look at another spec. Even numbers. I'll paste it in here. The even numbers in descending order from 70 to 50 inclusive. Okay, this time we're going to count down. We still have a counter-controlled loop, but we're going to count down from 70 to 50. So let's take our control variable, this count variable, and put in it 70. And we're going to count down to 50. We want inclusive this time, and instead of increasing by steps of 5, we're going to decrease in steps of 2. I wonder if we've gotten that right. Let's compile with F7. And then let's run it. I'm going to turn the breakpoint off for a second. Let's run it without the breakpoint, and we'll see that it didn't output anything. So the program ran, and it did not output anything. So you might be puzzled by that. Let's look at it. The spec says from 70 to 50 inclusive. We started at 70, and it looks like we have done something wrong with the stop condition. And we have decrementing by steps of 2. Okay, I'm going to put a breakpoint here. We have a logic error someplace, and we have to find out why our program ran, but it didn't do what we expected it to do. So put the breakpoint near the beginning and start executing a line of code at a time. Okay, the count variable has 70 in it. That seems to be working. While count is less than or equal to 50. 70 is less than or equal to 50. Is that true or false? Well, it's false. So the next line of code we execute is after the loop is over. We didn't do the body of the loop even one time. So we have our relational operator wrong. I'll just push F5 to get back into editing mode here. So when do we want to stop? While the count, I should really be saying what is the condition for which has to be true for us to continue? And this has to be true at least the first time. So let's try another one. While it's greater than 50. So the first time through count is 70. 70 is greater than 50, so it's true the first time. And should it be greater than or greater than and equal to? Greater than or equal to. Count is greater than or equal to 50. If that's true the last time through the loop, the variable count will be 50, which seems to be what we want according to the spec. So it's at inclusive of 70 and 50. When you're trying to decide what the relational operator is to end a loop, I encourage people to just write one down and look at it and see if they've gotten it right. That's easier than trying to make sure that you get the right one, trying to logic it out. So as a beginner, why not just put greater than in and see if that makes sense for the spec, for the loop to get going the way that you need it to, and if not, then change it. It's a good way to start out writing these loops. So let's run this. I'll turn the breakpoint off and we'll run the whole thing. And it looks like we have the even numbers from 70 to 50, and this time counting down instead of counting up. The next spec we have here has an interesting aspect to it. It's hard to talk and type at the same time. So in this spec, we're not just going to output something in the loop. We're going to sum the numbers from 1 to 100, and then we're going to output the result. Okay, we need another variable. We need one variable that will count from 1 to 100, and we need a second variable that will store the sum. So I can change this and add a variable sum, and I'll leave it like that for a second, and our count variable will start at 1, and let's say the loop goes count is less than 100. Do we want less than or less than or and equal to? Less than or equal to. While count is less than or equal to 100. Let's try that, and we're going to go in steps of 1. So each time through the loop we'll be working with the next value. And instead of outputting something each time through the loop, we're going to be summing something up. So we're going to say sum gets, what do we want to add to sum each time through the loop? Well, the variable that's counting from 1 to 100, we're going to add that into the sum. So let's take the old value of sum, add the count to it, and put it in the variable sum. And we want to, after the loop is over, output the value of the sum. Okay, statements that are inside the loop will happen over and over. Statements that are outside of the loop are going to happen only one time. They're not part of a repetition. There's a bug in this program, and I'm not sure if you can see it, and I'm not sure if it will cause us a problem, but I'll certainly point it out as we go along. First of all, let's run this program F7 to build it, and that succeeded. Now let's run it without any breakpoints and see what it does. Oh, we have a runtime check failure. The variable sum is being used without being initialized. And that's the bug. I didn't really know if it was going to be pointed out in a dialogue or if we were going to trip over it or something. But this is a very good C compiler from Microsoft. They don't let you get away with making mistakes. So we were executing this line of code, and what was in the variable sum to start with? When we came to this line of code here, we said sum gets sum plus count. Count has 1 in it, the first time through the loop. What did sum have in it? Look down here. Wow, minus 85, minus 858 million and something. Where did that number come from? This is a very common problem in C programming. We didn't put any value in this variable, and we decided we were going to use it the first time to add something to it. Because we didn't put anything in there, it was going to use the value that was in there before. The value that was in that variable was some junk that was left over in memory. And some large negative number, apparently. And that's not what we wanted to use in our calculation. So this was the bug that I had promised to show you. We didn't initialize the sum variable to 0 when we started. Okay, let's go and stop debugging. And now I'll put a breakpoint there and we'll watch the behavior line by line. F7 to rebuild this program, and now F5 will stop us at that breakpoint. And I'll make this just a little bit bigger. So the sum is now 0. That makes sense. The count is 1. So this is our first time through the loop. And if we start executing this, sum gets sum plus count. So we're taking 0 and adding what to it? We're going to add 1 to it. And then increment the count. The next time through the loop, we're going to take the old value of sum and add 2 to it. So we've got 1 plus 2. Now 3 plus 3. So watch the value of sum as it accumulates all of the numbers between 1 and 100. This is not an intuitive way to think of how you might sit down and add the numbers 1 to 100. You would probably do it all as one operation. And instead, in this loop, what we're doing is we're adding each of the numbers into an accumulator one by one. So the sum continues to get larger, accumulating the values of the count each time through the loop. So this will eventually stop when count is less than 100 is false, but I'm not going to click this button that many times. I'm going to turn this breakpoint off, and I'm going to put another breakpoint here. So when we say F5 now, this loop will continue to execute, and when it falls out of the loop, it will hit this breakpoint here on the printf statement. So I'll hit F5, and that executed very quickly, and the value in sum is now 5050. The value in count is 101. That makes sense because this condition must be false before the loop is over. So count became 101, and then the loop was over, and we output the value 5050. So we've got our program working that will calculate the sum of the numbers from 1 to 100. What would happen if we try to calculate the sum of 1 to 1000? I'll turn the breakpoint off, and let's run that program. The sum of 1 to 1000 is 500,500. How about 1 to 10,000? F7, F5. Isn't this an interesting pattern of numbers? So in this one, commas would help, wouldn't it? 50 million and 5,000 is the sum of the numbers 1 to 10,000. Very, very fast loop. You wouldn't want to step through that 10,000 times, but making the problem very small and then making sure that the logic is correct is a good way of getting started in here. Okay, let's go back to the slides now and look at the concepts that we've been working on in development environment. Well, that was fun, wasn't it? I thought so. I want to point out from this very first example that we typed in the development environment, there are kinds of variables called counter variables and accumulator variables, and we used both of them in these examples. A counter variable and an accumulator variable, that's not their data type. So in our example, we used int as the data type for both of them. The counter variable describes how the variable is being used. If it's used as a counter, each time through the loop, it will change by 1 or by 2, whatever the step is specified for that particular counter. And an accumulator variable, each time through the loop, the value in the accumulator will go up or down. I suppose you could accumulate things down. I try to tell people that accumulator variables are like buckets. They have something in them already and you throw more stuff in. So you are taking the old value in the bucket, add something to it, and that's the new bucket. So we throw something in the bucket each time through the loop, and you will pretty commonly find places in the problem specifications where you would need counters and accumulators. Okay, I want to introduce the concept now of a sentinel-controlled loop. The loops that we implemented in this segment up until now have been counter-controlled loops. So there was a variable that we called count, and it was used to decide when the loop would stop. So how many times does a loop repeat in a counter-controlled loop? We know the answer to that. And in a sentinel-controlled loop, we are looking for a specific value to find out when we should stop. So here's the specification that we're going to implement using a sentinel-controlled loop. Ask the user to enter test scores. When they've entered all the scores, they will enter the value -1. The program will sum up all of the scores and output the result. So the issue here is we don't know how many test scores there are going to be. If the class had 10 people or 100 people in it, we want the loop to go 10 times or 100 times. So we're going to use the data that the user is inputting to look for a specific value called a sentinel value. So we decide beforehand that a value of -1 is not going to be data. It's going to be entered by the user, and when we see that value, we will stop the loop, recognizing that all of the valid data has already been entered. So a sentinel-controlled loop is different from a counter-controlled loop in that we're using the sentinel value, in this example -1, to know when the loop should be stopped. So let's take this specification with the user entering the test scores and go back into the development environment, and I'll show you how to implement a sentinel-controlled loop. So get your development environment going as well, and type along with this. It will be a good way for you to remember how to do it. Here we are back in the development environment, and we have the spec. Ask the user to enter test scores. When they've entered all the scores, they'll enter the value -1, and that'll be our sentinel value. And the program will sum up all of the scores entered and output the sum. So let's declare some variables. It looks like our scores are going to be integers. So we'll declare an int score. We'll store 1 score in this variable, and we need a sum. And remember the bug from the last time, we're going to initialize the sum variable to 0. It will be our accumulator. So the first thing we'll do is we'll ask the user to enter a test score. And we'll tell them what the sentinel value is, the magic number they need to type for this thing to get stopped. -1 to quit. I need double quotes. And then we'll scan in the first score. It's an integer, %i, and ampersand score. Now, when we have a sentinel controlled loop, the first read is called a priming read. And now we'll start the loop. We'll make it a while loop. So while the score is not equal to -1. So what we're saying here is we want to keep going while the score is not equal to -1. And each time through the loop, we will take the score that's entered and add it to the sum. Sum gets sum plus score. And then we're going to ask them again for a score. So I'm going to copy these two lines and paste them down in here. The indentation is not correct. Remember how to fix that? We can do a Control-A, Edit, Advanced, Format Selection, and now these two lines of code are inside of the loop. When the loop is over, we're going to output the sum. Printf the sum of the scores is, and it's an integer, we'll put %i \n and we want to output the sum. I'm going to put a \n at the beginning of that as well. I'm not really sure I've got this exactly right, but that's what the debugger is for. So here's the format for a loop that does a sentinel controlled loop. We have a priming read. This is outside the loop. Before the loop starts, we ask for the first piece of data. And the while loop checks for the sentinel value. So the first time we ask for a number, the first thing we'll do with it is we'll see if it's -1. And if it's not, then we'll keep going. So this line of code processes the piece of data that was entered, and these two lines of code ask for the next piece of data. I wouldn't have expected you to figure this out yourself. This is a technique that has been around for a long, long time, and it's a priming read and a repeating read. So let's look at how it works in the debugger, and we'll use some test data with an expected result. So the test data is going to be 70, 80, 90. These are 3 test scores. And then -1 is the sentinel value. And our expected result is 240. So we expect these numbers to add up to 240. So I'm going to put a breakpoint here on the while loop, and I guess I haven't compiled this yet, so I might have a compiler error in here. We will check for error messages. I don't expect you guys to be able to type this much code without a compiler error. So look for the error messages and click on the first one to find out what's going on. Fix all the compiler errors, and then F5 will run to the breakpoint. So it says enter a test score, and we said the first one we enter will be 70. Let's look down here and see, yes, indeed, score has 70 in it and sum has 0. So 70 is not equal to -1. Is that true or false? It's true, 70 is not equal to minus 1. So when we execute the statement that is the while loop, we will go inside the body of the loop. Now accumulate the 70 into sum. So sum, which has 0 plus 70, and put it back into sum. And now output the message, enter a test score. And when you're in the debugger and you execute an input statement, a scanf, it will pop you back into the execution window. And we said the second value in our test set would be 80, so we'll type 80 and hit enter. I would have liked it to pop us back into the development environment, but it didn't, so we'll go back over here manually by using Alt-Tab. Now we can keep executing lines of code. So what we just did now was input the 80, the value 80, into the score variable. What's the next thing we'll do? Well, it's a while loop, so we'll go back up to the top of the loop and see if 80 is not equal to minus 1. It's not, so that means the condition is true. That's a little bit tricky. When it's not what you're looking for, then it's true. So we'll say sum plus 80 and put it in sum. There's the accumulator going up to 150. Ask for the next value. We said we would enter 90 for the next value. And keep going. Step over. 90 is not equal to minus 1, so we're going to keep going. Add the 90 into the accumulator. Ask the user for another value. And this time we're going to put minus 1 because we have no more numbers in our test set. This time we have minus 1 is not equal to minus 1, and that's false. So when I execute this while loop this time, it drops us out of the loop, and we come down and we can output the sum of the scores is whatever is in sum. And sum has 240. So we can pop back out and make sure that we got the correct message, the expected result. And it doesn't matter how many pieces of data we had, because we're going to enter the minus 1 at the end. A quick review then of the concepts that we've covered in this segment. We introduced looping or repetition in this segment, and now we have covered all of the three concepts of control structures in C programs. So the sequence, selection, and repetition. We looked at two kinds of loops, or two kinds of repetition, using the while loop. We looked at the counter-controlled loop and the sentinel-controlled loop. So a counter-control loop uses a variable called a counter that will be used to test to find out when the loop should stop. And the sentinel-controlled loop uses the data that the user is entering to decide when it's time to stop. When you're deciding how to make a counter-controlled loop, you have to ask the three questions. Where do I start? Where do I stop? And how do I get there? And if you study the spec that you're trying to solve and think about those three questions, that will help you to get the loop to behave the way that you need it to solve the problem. Two kinds of variables we looked at: counter variables and accumulator variables. And they don't have to necessarily be integers. Counters are almost always integers, but you might be accumulating double variables, for example, or some other data type. When you're solving a problem that uses loops, make sure that you have a test case, and that the test case, you can use that to walk through the loop and make sure that the behavior of the loop is what you expect, so that with this test data and this expected result, you have a definite target that you're trying to make your program work towards. I hope you're enjoying writing loops in C. It's one of the more challenging parts, and we're going to revisit it again in a couple of segments from here, and we'll solve some more problems using these new control structures. See you next time.